Mazda just announced the most important engine since the internal combustion era began, a 2.5-liter four-cylinder that simultaneously kills diesel efficiency as a selling point, exposes Toyota's hybrid strategy as a structural workaround, and gives Brussels regulators a combustion engine they have no legislative answer to. And we are not even in 2027 yet. The same company that most Americans struggle to name 3 models from just spent 13 years in silence, engineering a powertrain so philosophically threatening to the existing global auto order that German luxury manufacturers are quietly reviewing their inline-6 roadmaps, and Toyota's hybrid engineering team is asking questions nobody has a clean answer to. So what exactly did Mazda just announce? And why is the smallest mainstream automaker in the world now the most important one in the room? Subscribe because I break down every engineering story that reshapes this industry, and Mazda is nowhere near finished with what they are building. To understand how significant this is, you have to understand what the Skyactive Z actually does. Mazda's Skyactive engine family has been the company's defining technical identity since 2010. While Toyota was launching new hybrid systems every 18 months, and BMW was rolling out engine updates twice a year, Mazda spent over a decade refusing to announce a successor until they had something genuinely revolutionary. What they have now confirmed is exactly that. The Skyactiv Z is a 2.5-liter inline 4-cylinder gasoline engine that achieves lambda 1 combustion across the entire operating range of the engine. Not in a narrow window, not under ideal test conditions. Across the entire range from idle to redline, from cold start to highway cruise, from light throttle to wide open acceleration. Lambda 1 means perfect stoichiometric combustion, the precise air-to-fuel ratio where every molecule of oxygen reacts with every molecule of fuel, and nothing is wasted, nothing is left over. Every single combustion event extracts the absolute theoretical maximum energy from the fuel. That is not a marketing claim. That is a statement of chemistry, and it is the specific problem every gasoline engine engineer on Earth has been working toward for 100 years without fully cracking it in a production vehicle across the complete operating range. Mazda just confirmed they cracked it. Now think about what that actually means for everyone else in the industry. Every gasoline engine in mass production today drifts away from lambda 1 constantly. At idle, at cold start, under acceleration, at high revs, the mixture shifts rich or lean, and the engine has to manage those drifts with catalytic converters, oxygen sensors, variable valve timing, and exhaust gas recirculation systems that add cost, add weight, and add complexity to every vehicle they are fitted to. All of that complexity exists for one reason: because sustaining lambda 1 combustion across the full operating range was considered an unsolvable problem with conventional engine architecture. Engineers at BMW, Toyota, Ford, and Volkswagen have all attempted versions of lean burn combustion and walked away with results that were compelling in the lab and disappointing in the dealership. Mazda spent 13 years proving the limitation was not fundamental. It was an unsolved engineering problem with a solvable answer waiting at the end of a very long development road. The tool that makes it solvable is something called heat insulation technology. Masahisa Yamakawa from Mazda's Technical Research Center confirmed that heat insulation was the last of the 7 control factors for thermal efficiency that nobody had fully addressed in a production engine program. Those 7 factors are compression ratio, air-fuel ratio, combustion period, and mechanical loss. Mazda's previous Skyactiv G attacked 6 of them and produced the world's highest production gasoline compression ratio at its launch. The Skyactiv Z goes after all 7. Additionally, the Skyactiv Z incorporates new heat conversion technology that turns thermal energy normally escaping through the cylinder walls into useful mechanical output. Mazda has not yet disclosed the exact mechanism, but the engineering pathway points to either waste heat recovery through a Rankine cycle system or thermoelectric generation integrated at the cooling circuit level. Either solution represents a fundamental departure from how every current production engine handles thermal waste. And when you combine lambda 1 combustion across the full operating range with heat conversion technology that recaptures what would otherwise be lost through the cylinder walls, you get thermal efficiency numbers that no turbocharged competitor currently in production can match. Subscribe if you want to understand what this does to BMW, because that conversation is coming, and it is not a comfortable one for Munich. Now the announcements themselves, because the details are where this gets serious. The Skyactiv Z debuts in the next generation Mazda CX-5 in late 2027. That is Mazda's best-selling vehicle on Earth. over 4.5 million sold globally since 2012. It is not a niche model or a technology showcase. It is the commercial core of the entire company. This engine lands in the highest volume product Mazda builds, paired with Mazda's first fully in-house developed hybrid system. Not a Toyota-licensed hybrid setup the way the CX-50 currently uses. Mazda's own parallel hybrid architecture, designed from scratch specifically around the Skyactive Z's combustion characteristics. That declaration of engineering independence from Toyota is its own announcement inside the announcement. And here is why it matters, beyond the headline. Toyota's hybrid technology has been the efficiency benchmark for Japanese automakers for 25 years. Every smaller manufacturer that could not afford to develop its own hybrid system borrowed Toyota's platform and paid for the privilege. Mazda was one of them. The moment Mazda builds its own hybrid system around an engine that already approaches hybrid fuel economy numbers before the electric motor is added, the dependency ends. And the efficiency advantage Toyota built over a quarter-century of proprietary hybrid hardware investment starts to look significantly less permanent than it did 12 months ago. The Skyactiv Z will also meet Euro 7 standards and US LEV4 Tier 4 emissions regulations without a performance penalty. To put that in context, tweaking the existing Skyactiv G engine to meet those same standards would have cost approximately 30% of its power output. Mazda is hitting the world's toughest emissions thresholds without giving up a single horsepower. That is the number that should make every European luxury manufacturer sit down and reconsider their next powertrain investment cycle before committing another billion to a turbocharged platform that still has not solved the lambda problem. Then the inline six. Mazda has confirmed the Skyactiv Z combustion architecture is being scaled to a new inline-six engine for the larger platform vehicles in the lineup. The same Lambda 1 technology, the same heat insulation approach, applied to the engine configuration that BMW has dominated for 50 years. The B58 inline-six in BMW's current 3.5 and X5 is arguably the finest turbocharged inline-six in mass production today. It is smooth, powerful, and thermally efficient for a forced induction engine. It is also still fighting the lambda compromises that Mazda just eliminated. When a Skyactiv Z-derived inline-six enters the market meeting Euro 7, without mild hybrid assistance, and sustaining Lambda 1 across its full rev range, it is not competing with the B58 on peak power numbers. It is competing on the question of whether the B58's fundamental engineering philosophy was the right one to begin with. That is a conversation BMW's engineering leadership is not prepared to have publicly right now. Every inline-six program in development at every European luxury brand is being quietly re-examined in the light of what Mazda just published. And finally, the carbon pathway. Mazda's engineers have confirmed two parallel routes toward carbon neutrality that no other manufacturer has publicly committed to at the same time. The first is synthetic e-fuel compatibility. A Skyactiv Z running on carbon-neutral synthetic fuel derived from atmospheric CO2 capture produces zero net life cycle emissions because every carbon molecule it emits was previously removed from the atmosphere to produce the fuel in the first place. The second is zeolite-based exhaust CO2 capture. Zeolite is a mineral with extraordinary molecular adsorption properties at combustion temperatures. Mazda is actively testing zeolite integration inside the exhaust stream to absorb CO2 before it reaches open air. If that technology validates at production scale, a Skyactiv Z on synthetic fuel with zeolite exhaust capture is not a carbon-neutral engine. It is a carbon-negative engine. An engine that actively removes more CO2 from the atmosphere than it emits during normal operation. The more miles you put on it, the cleaner the surrounding air becomes. The European Union built its entire 2035 combustion ban on the assumption that no internal combustion engine could ever become carbon compatible. Mazda's engineering roadmap is not asking for a legislative exemption from that assumption. It is removing the factual basis the assumption was built on. Now here is what Mazda will tell you, and it is not wrong. The Skyactiv Z is a production engine with a confirmed launch vehicle, a confirmed timeline named lead engineers, and specific publicly committed performance targets. This is not a concept. It is not a research proposal. It is a 2027 production schedule, with real people accountable for real outcomes. But here is the counter-argument, that credibility requires acknowledging directly. There are viewers watching this right now thinking about the Skyactiv X, and they should. The Skyactiv X launched in 2019 using spark-controlled compression ignition technology as its efficiency mechanism and under-delivered significantly. Real-world fuel economy gains came in at roughly 9% over the conventional Skyactiv G on the WAL-TP cycle. well below the 20 to 30% improvement that had been communicated during development. The price premium was a 27% uplift over the base engine in a Mazda 3 that buyers could not justify given the marginal real-world difference. Early production reliability issues included injector carbon buildup at higher than expected rates, cold start misfires under certain ambient temperature conditions, and sensor sensitivity problems that caused the engine management system to drop out of compression ignition mode at inconvenient and unpredictable moments in daily driving. The Skyactiv X accounted for less than 5% of Mazda 3 and CX-30 sales in Japan at its peak. Mazda removed it from the Mazda 3 hatchback lineup entirely. Australia pulled it from the market. It never reached the United States at all. The gap between what Skyactiv X promised and what it delivered in the hands of real owners was real documented and genuinely damaging to Mazda's engineering credibility. But the Skyactiv Z is not Skyactiv X, with a new badge and a fresh press release. The engineering difference between the two programs is fundamental, not superficial. Skyactiv X was a 2.0-liter base architecture, attempting to layer compression ignition behavior onto an engine not designed from the ground up to support it. It used a Roots-type supercharger as part of its speechy combustion management system, adding a mechanically complex component with its own dedicated reliability exposure and its own distinct failure modes under sustained load. The supercharger added cost, added noise, and created a thermal management burden that compounded the core problem rather than solving it. Skyactiv Z is a clean-sheet 2.5-liter design built exclusively around lambda 1 combustion requirements from the first line of the engineering brief. Every component in the architecture, the injector placement, the piston crown geometry, the combustion chamber shape, the cooling jacket design, exists specifically to support sustained lambda 1 operation, not as a secondary consideration, as the primary design constraint that everything else was built around. The heat insulation technology in Skyactiv Z directly addresses the wall surface heat transfer failure mode that caused Skyactiv X to lose combustion stability at higher loads and revs. That was the exact problem that collapsed the earlier program when real drivers put it into real conditions across a full range of ambient temperatures, throttle positions, and sustained highway loads. Mazda has explicitly confirmed that every lesson extracted from the Skyactiv X program was incorporated into the Skyactiv Z architecture from the foundational level upward, not as a late-stage correction bolted onto a design that was already committed. At the architecture level, from the beginning, before the first engineering drawing was finalized. The credibility question is legitimate, and it deserves a direct answer rather than a deflection. Mazda overpromised with Skyactiv X. The real-world numbers did not match the development claims, and buyers who paid the premium for the technology felt that gap in their fuel receipts and their ownership experience. That history is part of the Skyactiv Z story, whether Mazda's communications team acknowledges it or not. But the counterweight to that history is this. The engineers who built Skyactiv Z are the same engineers who lived through Skyactiv X's failure in production. They did not read about the problem in a report. They spent years in test cells and on development roads, watching their own technology under-deliver, and then went back to the beginning to understand exactly why. That kind of institutional knowledge, the specific understanding of where a program broke down and precisely why it broke down, is not something you can buy or import or acquire through a corporate partnership. It lives in the people who experienced the failure firsthand and chose to solve it rather than abandon the direction entirely. Mazda chose to solve it. The Skyactiv Z is the result of that choice. Be appropriately skeptical until the 2027 production data exists. But understand that the most dangerous engineering announcements in automotive history have consistently come from small, obsessive companies that everyone else dismissed until the product arrived in showrooms and the numbers were impossible to argue with. But the Skyactiv Z is not Skyactiv X, with a new badge and a fresh press release. The engineering difference between the two programs is fundamental, not superficial. Skyactiv X was a 2.0-liter base architecture, attempting to layer compression ignition behavior onto an engine not designed from the ground up to support it. It used a Roots-type supercharger as part of its speechy combustion management system, adding a mechanically complex component with its own dedicated reliability exposure and its own failure modes. Skyactiv Z is a clean-sheet 2.5-liter design built exclusively around lambda 1 combustion requirements from the first line of the engineering brief. The heat insulation technology in Skyactive Z directly addresses the wall surface heat transfer failure mode that caused Skyactive X to lose combustion stability at higher loads and revs. That was the exact problem that collapsed the earlier program when real drivers put it in real conditions. Mazda has explicitly confirmed that every lesson extracted from the Skyactive X program was incorporated into the Skyactive Z architecture, from the foundational level upward, not as a late correction. At the architecture level from the beginning, will the Skyactive Z deliver everything Mazda has publicly committed to in real-world production use? We will not know until the 2027 CX-5 reaches independent testers and then real owners, but the engineering claims Mazda has made are technically grounded, publicly stated, and mathematically defensible in a way that Skyactive X's promises were not at a comparable stage. Take the track record seriously. Be appropriately skeptical. But understand this is the most consequential combustion engine announcement of the last decade, and the global auto industry is responding to it accordingly because the underlying engineering rationale is credible in a way the 2019 program never was. Now look back at where this started. 13 years of silence from the smallest mainstream automaker in the world. Not because they had nothing to build, because they refused to announce anything they had not yet built correctly to the standard they set for themselves. The Skyactive Z is the product of that refusal. Lambda 1 combustion across the full operating range. Heat conversion technology that recaptures thermal energy every other engine discards. Euro 7 and LEV4 compliance without any power reduction. An inline 6 expansion walking directly into BMW's most commercially defended engine segment. A carbon-negative pathway that makes the 2035 combustion ban look like legislation constructed on a factual assumption that has now been overtaken by engineering reality. Mazda did not get here by chasing trends or reacting to regulatory pressure. They got here by deciding what the correct answer looked like and spending 13 years building it without announcing anything until it was ready. So where does this go from here? The 2027 CX-5 launch is not a question of if. It is a question of whether the production numbers match the engineering commitments in the real world in the hands of real buyers, driving real roads in real weather conditions. Right now, every major powertrain engineering team at every major automaker is running the same calculation against what Mazda just published. If the Skyactiv Z performs the way the development data indicates, the answers those calculations return are going to be deeply uncomfortable in Wolfsburg, in Munich, in Toyota City, and in Brussels. I will be here with the independent production numbers the moment real-world testing data becomes available. If you own anything with a combustion engine or a hybrid badge, go understand what sustained lambda 1 combustion means for the vehicle you plan to buy next. And subscribe because I cover every one of these engineering stories the moment the verified data lands. Mazda is not done, not even close. The next decade of this industry will be defined by who matches what they just built, and who spends it explaining why they did not.